Alright, team, it's your boy the Canologist, and I'm going to be doing the Hamming distance. Hamming distance between two integers is the number of positions at which the corresponding bits are different. Given two integers x and y, return the Hamming distance between them. Okay. Hamming distance. Information theory, Hamming distance between two strings or vectors of equal length is the number of positions at which the corresponding symbols are different. In other words, it means the minimum number of substitutions required to change one string into another. Equivalent, the minimum number of errors that transformed one string into another. Okay, so basically, positions at which the corresponding bits are different. X is 1, Y is 4. Explanation, the Hamming distance is 2. So let's break open the whiteboard and let's figure out why we need to do this from scratch. It's your boy the Canologist. I'm not a biologist. Okay, so for example, we got x and y equals 1 and 4, so x equals 1, y equals 4. I believe they're doing the Hamming window based off of this principle. So 0, 0, 0, 1 in a 4-bit byte. Then we go 4. So this is 2 to the power of 0, which is 1. X equals 1. X equals 4. And what I'm going to do here is 2 to the power of 0 to the power of 1 is 2 to the power of 2 is 4. So 1, 0, 0, 0. What they're doing is saying the Hamming window is difference of error. So what would have to change in this string for how many positions would it take to fix it to make it this? So it'd be 1, 2 positions. So output is 0. So output is 2. See that? Now we could do the same thing with 3 and 1. So for example, same thing, 1, 0, 0, 1. So x equals 1. Y equals 3. To the power of 0 is 1, and to the power of 1 is 2. 0, 0. So the positions aren't different, so I don't have to shift positions. So we 1, 2. This one stays the same, so I only have to change this position that's different. So that would be output of 1. So number of errors, basically. Now the way I kind of see it is, let me look at an XOR gate. XOR 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. Oh, because it only looks at the OR condition, exclusively OR. That's what it means. Uh, and that's actually kind of what we want. All this is an exclusive OR gate, basically. That's what I'm seeing here. That's what my brain is like deducing from this. Between two integers, position at which, given two integers between y. So if I want to find errors and I'm comparing binary strings, all I have to do with binary strings is run an exclusive OR gate between them. You see what's happening there? So to run an exclusive OR gate between them, or I could the only thing I have to do is, so for 0, 0, I can't, 0, 0 and 1, 1 mean the positions are the same in both. We only want to see if there's a mismatch to count the number of differences. So exclusive OR gate is the way to go. So like now it's time to cook this up. Let's cook the books. Or I used to have a teacher that used to tell me the story about Enron and Arthur Andersen and the shredding of papers. And like every time one of these finance bros went to the shredder, someone's like, "Oh, Arthur Andersen, you look at you shredding the documents." Like, it's so corny, but it just brings a smile to me. You know what I'm saying? But yeah, let's cook the books. Let's cook the books. Okay. So my first step is going to be exclusive OR in Python. How do you get the logical XOR of 2 in Python? There we go. Bool A, this symbol, logical XOR, so logical XOR function is implemented like this. Let's try this on Python Playground. You guys see now? Almost every freaking lesson I do, I go to Python Playground. So someone, and it's probably gonna be me in the future, right? I'm gonna build some sort of Leetcode type-esque thing with a Python Playground built in, so I don't have to keep going to it. And then I want to also have some sort of AI helper. I want to reduce the number of times I get stuck and have to stop. Most of the time people quit programming because they get stuck and they just give up, right? But if you had tools like this, you'd have more opportunities to try. And that is what the goal is. First, I want to see what each thing does. But then I want to figure that other part. Okay, so 1 is true, 0 is false. Okay, so if we have See? So it does follow the principle and spits out the numbers. So what I'm going to do here is convert these two to binary strings. So we're going to say x, or binary Yeah, so binary it's going to be bin underscore x is going to be binary x 2. So that creates the string of a binary string of x. I'm going to create a binary string of y, bin y 2. This gets rid of the 0b at the front of the binary. It's usually 0b string, right? So this gets rid of that 0b. Then I'm going to create an array called stores. Or actually, no, I could just create a count variable. Count equals 0. Actually, let's do the stores method as well. Let's just make it bulletproof. Stores so binary string for position in range thing. So then we're going to go if bin x at position So if this equals 1, exclusive OR, then I want to increment the counter. And then I want to return the count. So technically I don't even need the stores. I could delete that and just run this. This should pass the test. Out of range. Okay, how to make sure. Binary strings equal length Python. There's got to be a way. All right, let's use ChatGPT for the purposes, not of solving it, but of answering the question. Make Okay, so we found the maximum length of the first and second string. We get the max number. Pad both strings with 0 to match the max len. Example usage. Okay, so that's a good strategy. Z-fill. So let's do that. So bin x, so len. Max length is equal to padded bin x equals padded bin x equals it's going to be bin x zfill max len. Then I go control X, oh wait, control V, enter, control V again. I do this just in case, in either case, if there's a swapped version of whichever one's the longer string, it'll make them both the same length. Then I can go padded. I just add padded here. So now all I'm doing is still the exclusive OR operation and just counting. So whatever is exclusively OR, so this will be a position 1, so that's 1. This will be position 1, that's 2. Alright, so 2. This will be a position 1, that's 1. No, this will be a position 0. This will be a 0, this will be a 0. This will be a position 1 because there's a difference. So that's 1. 1. So that's what I'm trying to aim to do here. Should pass. Did I spell it wrong? An integer is required. Max len. Oh, is that why they do this? Okay, so why? An integer is required. This is a freaking integer. What's going on here? Let's try this. Why? Why? An integer is required. Max len is the largest integer, is it not? Max. Oh, max len. Oh my god, I'm fucking stupid. Okay, so I can get rid of this. I messed up. Okay, so I have to put max here to get the maximum between len 1 and len 2. Well, I extrapolated that, so I need this back. So I just have to put the max here and I'm done. This should pass and then we should be good. We should be good to go. That will, what? How's this not thing? Exclusive OR 0, 1. Oh, because it's going len bin. It should be len padded. That's why. Make sure they're the same. That should solve it. What did I tell you guys? What did I tell you guys? What did I tell you guys? Ed, it's your boy. It's your boy. Wait, let me put the camera on my face for a second. It's your boy. It's your boy. Okay, let's go back and I'll explain exactly what I did. So, what happened here is first I look at these, I look here and this explanation gives me a clue. It turns both numbers into binary and that's how it's counting positions for this Hamming distance. So what do? Being the bright genius. Wait, I just want to make sure that I don't need this string property first. Because I'm pretty sure it already turns it into a string, but I just want to see. And there you go. Okay. So, like I mentioned, right? So I start by seeing that, okay, so they turn these two numbers into binary and then they're comparing what is a positional error. A positional error is when one element does not match the element in the other, in the corresponding number. So for example, 1 and 0 is a positional error because it's different, right? 0 and 0 is good. It's not a positional error because they're both the same, right? And 0 and 1 is a positional error, right? 1 and 1 is also not a positional error, like here. 1 and 1 is just, you still get 0. 0 and 0, you get 0. 1 and 0, you get 1. 0 and 1, you get 1. So what that tells me off the bat is, okay, this Hamming window is only looking at the numbers that are different in the same positions. So what does that tell you? Right? That tells you that it's not just an OR gate, because if you have an OR, if you just use the OR condition, 1 and 1 still gives you 1. So you're gonna have an incorrect count. Right? So I want an exclusive OR. It only looks at when there's a 0 and 1 or a 1 and 1. Only those two cases is when you get a true, right? Because it's exclusively if it's an OR. The OR gate is not exclusive because it counts 1 and 1, 0 and 1, and 1 and 0. Right? So let me just draw this out for you. This is in OR gates. 1 and 1 gives you 1. 0 and 1 gives you 1. 1 and 0 gives you 1. 0 and 0 gives you 0. So all these cases produce a 1, produce a true. We don't want this case. So I want to use exclusively OR. It's called exclusive OR because it only looks at when one of them is 1. So for example, let's go through here. 1 and 1 is 0. 0 and 1 is 1. 1 and 0 is 1. 0 and 0 is 0. So now I have this condition where this is true. So now when we go back to the code, I convert to binary, I get the lengths of both, but now the dilemma is I need both these binary digits to be the same length so I can compare them at each position to see whether they satisfy this XOR condition. So what I do next is I create a length. I get the lengths of both. I get the top length of whichever one is which, right? And then I pad the left side with zeros, right? So let's even look at this, right? It could be 0, 1, and then 1, 1. So that's translates to 1 in decimal, translates to 3 in decimal. This translates to 4 in decimal, right? So let's say I go 4 compared to 3, right? If I go 0, 1, 1, 1, 0, 1, 0, and then there's nothing to compare to this 1. So I have to pad this with an extra 0. So the reason, then if you're asking why do you do both, it's, let's say the question, like let's say it fills to the max length. So if you're already the max length, it doesn't pad anything, right? It doesn't hurt, right? The reason I do both is because when you run like how many test cases, it doesn't show the test cases, but let's say there's like 100 test cases, right? In some cases, the X might be the longer one. Some cases, the Y might be the longer one. So I just do both. So in any test case, it still passes. I'm just making it bulletproof for any test that comes its way. So both strings are equal. Now equal in length. Now I create a counter. So anytime I see an error, so anytime I see one of these XOR conditions pop off, I'm going to count how many occurrences, right? So this operator, this little hat, we call it a hat, or it's like an exponent as well, like use it for exponents, but this is an XOR operator. So if I look at the integer, because I have to compare the integer versions of these are two strings right now. So if I compare integer and integer XOR, I should get 1. So if it meets this condition, I should get 1, and in that case, I want to count. So for this one, 0, 1, 0, count goes up by 1, 0, 0, nothing, 0, 1, count goes up by 1. So now we're at 2, 0, 0, nothing. So we get an output of 2, right? And then we go 1 and 3, 1, 1, 0, nothing to the count, 0, 1, add 1 to the count, 0, 0, nothing, 0, 0, nothing. So you get output of 1, right? So once we go through that, now we can accurately count all the errors in positions at each position. And as you can see, pass the test cases and it passes the submission. So that's how you do hamming distance. If you like this video, please give it a thumbs up, subscribe, and comment below. Knologist out.